it's always much more effective and efficient to push than to pull. And when you're talking about the energy requirement, you're talking about anywhere from 6-to-1 to 5-to-1. All we had to do was find a way to get it out. And the rest, the market did it for itself.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about getting more production from the wells that produce natural gas. My guess says between 20 and 40% of all natural gas found in these reservoirs is still recoverable. The problem is that it's not been easy to create enough lift to get it out. Gas in these conventional wells typically rises to the top on its own pressure provided by Mother Earth. Until now, the only way producers have been able to get more out was to create a vacuum at the surface and suck it up from the top. That solution is problematic. First, imagine trying to suck up the last ounce of your favorite beverage through a straw. Now imagine that straw is a mile long. You're probably getting a headache just thinking about it. Same thing is true for gas producers. There's also the physical challenge of losing valuable condensate, the liquids found in natural gas, as everything's hoovered up to the surface. The condensate becomes heavy and drops out, or you have to wait until enough condensation collects before it can be pulled to the top. My guess has a novel solution that they say is an industry first. Rather than employ energy-intensive compressors to create a vacuum at the surface, they devised a skinny compressor that can be slipped down the well and push that gas and condensate up to the surface. It's a solution they claim is 5 times more energy efficient. You've heard me say this many times on the podcast. I'm always fascinated by innovations that make better use of the energy we need. This solution is a novel approach to creating a lighter lift for natural gas. My guest today is Herman Artinian, President and CEO of Upwing Energy, an end-to-end natural gas tech and service company based in Cerritos, California. Upwing was founded in 2016. Herman joined the company a year later. Their subsurface compressor system, or SCS, was first announced in 2019. Over the last year, they've begun permanent deployments. In addition to the increased production from conventional wells, the company claims this process is more energy efficient to the oil and gas industry as a whole. Upwing is currently focusing their SCS on conventional wells, or those that don't have to be fracked. While over 80% of today's wells are unconventional, there's thousands of conventional wells with that 20 to 40% of gas still waiting under the surface. Herman says for each conventional well that may have been drilled years ago and could now produce again, you don't have to drill and frack a new well. The energy needed to frack, pump, and produce hydrocarbons from these new wells equals a carbon offset of about 8,000 tons of CO2 per well and as much as 40 million tons of CO2 per year. That means we get the same immense benefits these hydrocarbons provide us at a much smaller overall footprint. We'll be exploring the new math oil and gas producers are considering when it comes to the energy needed to make energy in this and in future episodes. I hope you enjoy my conversation with Herman Artinian. We're here with Herman Artinian, CEO of Upwing Energy. And Herman, I've spent several years in the fracking sector. Before that, I worked with the carbon capture folks, and we spoke a lot then about enhanced oil recovery. We're using CO2 to help recover more oil. Let's start from the beginning. You talk on your website about artificial lift. What is that, and how does what you're doing differ from that?
Yeah, good question. As you mentioned, there are a lot of enhanced recoveries or artificial lift when we talk about oil or liquids, right? CO2 injection is one, pumps is another, water injection is another. Now there's gas lift. They're trying to lighten up the density of oil to bring it back to the surface. So all these secondary or more methods do exist for oil. However, there's nothing that really exists for natural gas. And our artificial lift is very specific to that, to bring up all those unrecoverable assets up to now, to bring them up to the surface. And we do that through an artificial lift, enhanced recovery, which we're using a compressor. Since it's gas, it's compressible, so we need a compressor to pump them up to the surface. Application is very similar to ESPs, electric downhole pumps, but this is a compressor and not a liquid pump, if you will.
What about the formation? These formations underneath are rock using compressors. Does it matter what the formation looks like?
The formation matters in regards to how much more incremental production and or recoverability we're going to be able to achieve with a certain compressor ratio of a compressor. So we're going into existing assets, means these have been producing for some time. So there's a lot of background data that's been accumulated. So we understand the connectivity of the reservoir. We understand a lot of the characteristics of the reservoir. We could really hone down and calculate how much compression we really need and what results will we get with those.
There's a lot of companies that do this kind of work. You mentioned that your technology is a little bit different because it's using a compressor that's essentially downhole, right?
That's right.
Yeah. And so how else have they been doing this kind of work in the past, the other competing technologies?
We are really the first of, so we don't really have any competing products that does what we do. We are compressing the gas as close as we can get to the reservoir and pushing the gas along with all the liquids or whatever else that's mixed within the fluid up to the surface. Up to now, only thing that operators are able to do is reduce the gathering line pressures so that the reservoir doesn't have to fight through a lot of pressure to bring its gas to the surface. However, that has significant limitations, especially with the wells that have a lot of liquids in them. And these liquids are not just water, but condensates that want to come to the top. And along its journey, as the pressures drop, they separate. And hence the condensation takes place. And that's why we have the term liquid loading in natural gas wells, where the liquids drop out of the gas and they create a barrier or a drag friction on the wellbore that's about 2-mile journey, and it's not going to make it. So no matter how much you create a suction from the surface, that's not going to change this behavior. Only way to offload these wells is if there's enough liquids, you could suck the liquids, but that's very temporary. So you have to be in this constant removing the liquids, and will produce for a while until more liquids are developed in the well bore. Our device continuously pumps the liquids up to the surface along with the gas, plus creates a significant pressure drop in the reservoir. So significant drawdown on the reservoir so that we are able to not only increase production sustainably, but significantly increase recoverability, which no other product does today.
Yeah. Do you have to change the size of the wellbore or anything if you're adding a compressor to it?
Right now, our tool is 5 inches in diameter. So we're focusing on wells that are 6 inches in casing or bigger. We will have another product down the road that manages to go into a 5.5-inch casing. We've done prototypes already, so that's well underway.
And so what would it look like if you were doing a greenfield well? You said you're going into existing wells, but what if you designed a well with this in mind?
That's a good question. Currently, all the new drillings have been in the unconventional side, especially in the U.S., right? Initial year into life of these wells, it doesn't need help. It has a lot of pressure. It's just waiting for that release. The real question that we need to answer together with the operators is, when is the right time to insert the tool? And it's not just economics based. It is really a technical challenge, because before all your frackings and all the sand gets disappear, when is the right time to get the maximum output from these wells? And that's something that we're going to need to experiment and play around and come up with the right timing. But currently, all our deployments are in conventional assets. They've been producing for decades, and there is minimum 20 to 40% of the recoverables that's still sitting down there that they cannot produce. And that is a significant number of gas production, not just in the U.S., but globally, Middle East, North Sea, and in Asia.
Yeah. On your website, it says you can increase revenue, boost production, and eliminate a lot of the CO2 in terms of the energy needed to simulate wells through conventional means. How is this process more energy efficient?
Sure. So 3 different ways. Number one, it's always much more effective and efficient to push than to pull, since that's why we invented the downhole pumps, right? Otherwise, we would have just put the pumps on the top side. And when you're talking about the energy requirement, you're talking about anywhere from 6-to-1 to 5-to-1, right? For the same amount of gas, to push it from 2 miles below, you need 100 kilowatts, let's say, and you're going to need 500 kilowatts on the top side for the same amount of production volume if you were sucking it. So that's number one. we're reducing the amount of energy that's utilized. Number two, in most cases, the industry drops the gathering line pressure through compressors on the gathering lines. And these compressors typically operate with the internal combustion engine. And these are rotating equipment with seals, and these seals leak. So EPA's study that went on for 3 years that basically provided a baseline of what is being emitted. And most of the time, it's not just the emissions of the engine, of the exhaust, but it's the leak of methane through the seals of the compressor. And that's somewhere around 280 tons of CO2 equivalent per month per compressor. That's the one we eliminate for sure. Number two, we need a certain rate of production to meet our energy demands. And today in the United States, talking specifically about natural gas, this comes from drilling and fracking unconventional assets. Roughly about 85, now it's getting close to 90% of our gas is produced through the unconventional in continental US. Well, with each tool that we insert into a conventional space, the 10-year production forecast for this tool matches exactly similar to what we could produce drilling and fracking a brand new well in the Marcellus Shale. So the 10-year life of a new well that's drilled and fracked, we could produce from an existing asset with our tool. And what we're saying is we could offset. We're not saying we're going to stop the drilling and fracking, but we're saying we could offset it. So instead of needing 5,000 a year to be able to match our consumption in U.S., every one deployed will save one drilling. They'll be equivalent to it. And that's roughly about over 8 million tons of CO2 one-time use for the drilling and fracking activity.
I see. So when you say the need to, quote, drill and frack a new shale well is eliminated, you don't need to frack because you're thinking you can get that gas out of a conventional well. Okay. So you're not, this isn't an alternative to a new formation that would normally be fracked. Okay.
That's right.
Interesting. I think this is a part of a larger conversation about the energy need to make energy. For instance, in the early days of fracking, about 2011, I would sit on the frack side and watch 20 diesel-powered pumpers frack a site. And it seems to me like it took a lot of fuel to make that fuel. Who knew where the diesel came from, what part of the world? Now, I'm not familiar with this metric, but there's got to be a energy needed to make a barrel of oil or a MCF of gas. What is that metric, and how are you measuring yourself against that?
You brought up a very interesting point. Similar to your history, I've managed and created companies on renewable space, energy efficiency space, energy storage space, and waste heat recovery space. And these are all companies that we formed, and we try to execute certain things in the United States. And economics never panned out in the United States, right? But that's a separate point. I've also worked on the first one of the guys that worked on electrification of fracking with my short stint at FMC Technologies, where they make the pumps themselves. Things are improving, for sure. So it's very unfair to say how it was in 2001 or 2010 versus how it is today. Things are definitely improving with regards to how we consume the energy to drill and how we frack. And it's ongoing, and I'm all in favor of it. However, it is necessary to drill and frack because we don't have any other conventional assets if you're looking for fossil fuels. That's number one. And no matter how effective we get, there's still a significant chunk of inefficiencies as well as emission that we output. Today, I think we're at the forefront in the U.S. than any other nation. Equinor definitely is in the forefront when it comes to offshore. They are doing amazing work, but it comes at a cost, right? So nothing is free. So I don't have a direct matrix for these things. And I know Equinor does measure it, and they put out their tables, and I think everyone should, including the second tier, third tier, all the oil companies, I think should. I think that's a great metric to follow, but it's not going to be eliminated. This assumption in 2030 or 2035 that we're going to drill, frack, and produce without any carbon offset, it's just not real.
But yeah, I think the big metric that's always been measured with oil and gas seems to be the price of oil, the price of gas. You know, that's how efficient you're going to be, right? Well, I definitely learned that when I was in the frac services company. It was wheeling and dealing in 2012, and then you hit 2014, and you find you got to lean up quite a bit. But it does seem like there's definitely an emphasis on the oil and gas sector to reduce the amount of CO2 or carbon to produce oil and gas. And Herman, tell me, when did you see that really come into focus? When did you see oil and gas companies really talking about the amount of CO2 that they're taking to make hydrocarbons?
Our journey started a while back when we were trying to put in projects for energy recovery and energy storage in the United States. And this is going back to 2000. And we realized that this wasn't economic in the U.S. So we would go to regions of the world where the energy prices were higher or they had regulations against emissions. So that's where we focused, right? When we stepped back, what needed to be done and what we were utilizing with regards to all fossil fuels that we rely heavily. I think today over 85% fossil fuels that we provide energy in the United States. We quickly came to the conclusion that the cleanest fossil fuel out of all of them is natural gas. And it's by leaps and bounds. Second, we came to the conclusion that, hey, we not only need natural gas for energy, to make electrons, but 1/3 is used for products, for plastics, for ethanol, for all these other uses that we take for granted today in our everyday life. And the other third was really direct use of industries, whether it's cement production, steel furnaces, and residential. Then we said, wait a minute, here's a very friendly, I guess, out of all the fossil fuels, and we're only using 1/3 of it for energy while we're still burning coal or burning kerosene with all these emissions. And yet we still have abundant of it. By the way, 40-50% is still underground. We know where they are, but we just can't access it because the technology is not there. So that deflection point was 2011, 2012. And we said, we are willing to bet what we have and what we know on natural gas, because eventually things will line up and natural gas will be the winner energy source, because we still need it for all the other applications. And so our mission really became how to cost effectively and sustainably bring up that remaining 30 to 50% of the natural gas that we know exactly where they are. There are no exploration charges. There is no cost associated with building infrastructure because it already exists. All we had to do was find a way to get it out. And the rest, the market did it for itself. And that's what we aim to do. And that's what exactly where we are. And I think we were pretty right with regards to the need of energy with all the LNG facilities. We're going to need as much as we could bring up to the surface. But both the industry as well as the people around the world, they do want it to be sustainable.
Herman, you mentioned electrification. A guest I had a couple years back was Evolution Well Services. You mentioned electrifying the fracking fleet. Evolution was a company who's doing that. This compressor is electrified, right?
Yep.
Okay, so the power source, I assume, is coming there from the site. What's your plans to electrify it? I mean, hopefully you're not having to use a diesel generator, but most of the time, that's what you got.
Most of the time, that's what you got in some places. But because we're pushing the gas and not pulling the gas, we need 150 energy. The power we're looking for anywhere from, in the United States, 50 to 100 kilowatts. So it's very little power. We're lucky enough that we have an unbelievable infrastructure for electricity grid. Within a mile radius, we're always, so far, have been able to find the electric grid to be able to bring the power. However, in the Middle East, what we are about to do is, since they have vast amount of land and a lot of sunshine, we are putting together a package with our partners there to be able to produce this via solar panel with the batteries to store at night when there's no sun power available. But it's still connected to the grid because it needs to work. But I think 90% of the load will be able to take off from the grid because of this combination. But that's very unique to that geography. So we'll have to work through how we try to make it, if the operator is truly interested in making it 100% emissions-free production.
Yeah. I also want to point out one of the services you have. You also talk about on your website, your end-to-end production service, and saying that the services are fragmented. But I thought the Weatherfords and Halliburtons of the world did that. So what do I misunderstand there, and what do you bring to the table?
Yeah. Right now, there's a lot of services and a lot of technologies that exist for oil. Because of its price point per barrel, it made a lot of sense for them to develop a lot of tools and services around it. For natural gas, there hasn't been any tools for enhanced recovery. Hence, no one really invested any dollar amounts or R&D efforts, number one, to digitalize the gas fields, and number two, to really spend the time and the reservoir to understand the details of what we could do, because they had no tools available to do anything about. So why waste the time in studying it? So there has been a big gap here. We're coming in. Not only have we developed a tool, but we've developed an application, an industry which didn't exist. Along with that, we had to also put our arms around the application. That meant more sophisticated tools to evaluate and analyze, to really dive deep into what happens to this 2-mile journey of the gas with condensation, which no one cared about up to now, as well as someone to put the services together, because operators really interested in incremental production. Nobody wants to buy another tool. Nobody wants to go and invest their engineering horsepower to understand and then be frustrated because they can't do anything with that information. So we bring all of those together. We remove the human resource element from them. We are there to analyze and evaluate and explain exactly what the situation is and how and what our tool does to enhance their production. And then we're there to deploy and operate the tool. So we're really one-stop shop that is there to help them recover and produce more than what they're able to do today. And that kind of service doesn't exist. And the old side probably doesn't exist because there's a lot of players and there's a lot of energy of the operators that's going into calculating how they could produce more. But it hasn't been done on the gas side. I think within a year or two, just like we're seeing with electric cars and charging stations popping out everywhere, it's like the chicken or the egg, right? So now that we have the tool available and the possibilities of enhanced recoveries available, I could see that a lot of operators want to jump in this field because it's a brand new field, it's untouched, and we have equal amount of gas wells as we have oil wells in the world. So I think they will come, but someone has to start the process.
Yeah, why not you? So what is next for Upwing Energy? Is the SCS, the compressor, is that ready for commercial service? Are you ready for widespread use?
Yes. For the past few years, we've been doing nothing but trials, not just stuck in the laboratory here. We've been out in the field, deploying under various rock conditions or well types, if you will, reservoir types. And this year we have started deploying these units on a permanent basis, as well as we have a couple of them running already. So we have a great base to start with. And then we are also in parallel going international with it. So you will see some announcements with us working in South America, in the Middle East, and in Europe. We spent significant amount of time making sure not just the tool, but the application we understood very dearly. And we're rolling it out now.
That's fantastic. That sounds like an exciting time for you guys. All right, Herman, I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas. You guys.
Big winner.
Crude oil.
We still need it.
Nuclear.
Definitely a must.
Coal, and I'll add coal with carbon capture.
Coal, I think, needs to be eliminated. Carbon capture is still questionable with regards to how sustainable it is.
Wind.
Where it fits? Absolutely.
Solar.
We are blessed in California. I have one in my house.
Biofuels.
I'm not in favor of taking food away from 3 billion starving people just to make fuel.
Hydroelectric.
I love it.
Geothermal.
Fabulous. I spent 5 years of my life with geothermal project.
Energy storage.
A big fan, and it still hasn't been resolved yet.
Energy efficiency.
That's the easiest thing we could do, and we must.
And then finally, fusion power.
I don't think my grandkids are going to see it.
All right. Herman Artinian, Upwing Energy, thank you so much for your time.
Oh, pleasure. Thank you. It was a blast. And it's great that you have the vast amount of experience with regards to not just fossil fuels, but also a lot of renewable energy. So it's fabulous.
Do what I can. Thank you so much, Herman. That was Herman Artinian, President and CEO of Upwing Energy, California-based natural gas technology and services company. I want to thank Herman for his time, as well as Jonathan Gelb and Carly Pearl at Diffusion PR for setting this up. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram at Host Energy and Twitter at Host Energy Cast. All guests are sent the wrong completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 178. Be sure to join us next week when we explore how the cloud is extending the lives of energy storage projects. Until then, I'm Jay Downhauer. We'll see you next time.